the screen?
Okay, sir. Visible. Yes, sir.
Okay. So thanks for your nice words and a very brief introduction on me. And quite interesting to know that there are people from a non-computer science background, commerce, linguistic, etc. Machine learning is the topic of today's webinar, which is a topic or the area of research of my interest, which I have been pursuing for the last roughly about 25 years minimum. And as Dr. Nanjan Swami said, there were about more than a dozen or 2 dozens of students who are graduated from my laboratory. I worked on this topic of machine learning for the last roughly for a period of 2 decades. So we have been exploring various use cases, helping citizens to be effective and efficient in their respective activities. So please, I request all the participants to mute your audios, please. So unless I insist that you keep your mic unmuted and respond to my questions, or you are requested to ask questions, please keep your mic otherwise muted. So the interest is on making systems intelligent enough so that system can be used not to replace human individuals or any a professional, but to assist him. We are looking for some AI-enabled, artificial intelligence-enabled solutions as a supplementary tool to make a teacher more effective, a doctor much efficient. So an orthopedician can make a quick decision with the support of computing technology. So it's not to replace any doctor, it's not to replace any engineer, but to give him a good enough computing tool so that instead of processing 10 tasks a day, perhaps he becomes capable of processing double of them. Right? So towards the target, we have been pursuing various use cases. Probably in my lecture, within a specified time of 90 to 100 minutes, my interest is just to present you the use cases without taking you much into the mathematics of the problem which we have solved so far. So let's understand what is this learning, what is this machine learning, how is it different from conventional artificial intelligence, and what is the current trend today. And for a budding technocrat, need not be a computer research scholar, could be a research or a faculty member of commerce or economics. Where are the opportunities and what are the challenging issues that one can take up and pursue and think of contributing something for the today's technology. Okay, so that's my interest today. Let's begin understanding what is this learning all about, right? So learning is to create intelligence. Learning is to acquire knowledge. Learning is the process of understanding the things, or to acquire some skill on the topic of my interest. So we have been into a learning, right? Since day number 1, soon after a kid takes up a birth, it starts learning. It observes. It uses its sensory organs like eyes, skin, tongue, right? So it uses these sensory organs and then learn a lot. And as and when it learns, it picks up a new skill to handle the problem in hand. I mean, ultimate job of learning is to make myself good at handling of current scenario, current problem. I mean, I just want to be good at problem solving. That's what the learning is. Learning is a process of acquiring. So I don't end up being only a learner. I want to create a knowledge based on that learning. So learning ends up with the creation of a library of knowledge. So once the library of knowledge is created, then how well I can make use of that created library of knowledge to handle the subsequent task is the question, right? So I may come across with similar situation. Then how do I handle it? So then I have to have a library of knowledge, and I have to have a powerful way of retrieving that knowledge and applying that knowledge at the right time for right, to make a right decision. So that's what is called intelligent. I mean, intelligent is an ability to solve a problem. So that ability has got to be uplifted every time as and when we are into learning. So when you attempt a new problem, which you are not come across so far in your life, but still you are capable of solving it because you have experienced, if not the same problem, something similar to that problem. Or if not a single problem, something similar to such problem, perhaps maybe several. You just have union them. You just have go with a collective knowledge, and then solve this new problem, which could be split up into multiple subtasks, and each subtasks match against some task which you already solved. So this is my ability, right? So I mean, initially I learn, I cognize. Perhaps when Dr. Nanjan Swami got myself introduced to you people, you just have cognized about me. You just have learnt about me, right? And tomorrow, if you happen to listen my lecture without seeing my video, so because you are now listening my lecture, you are hearing my voice, perhaps in your knowledge base, my voice gets recorded, the style with which I speak, the fluent which I just speak, you just get everything recorded. And tomorrow, in case if you happen to hear my voice without even seeing me, you say that, oh, perhaps this appears to be Professor Guru, right? It seems to be a Professor Guru. How do you do that? So that's what I call it as relearning, right? Relearning. It is learned, but again you are learning about. So that's called relearning. Relearning means is exactly like cognizing and recognizing, right? So cognition is at one end. Cognition is to acquire knowledge, whereas recognition is to reacquire the knowledge and the same object of interest. So that would help you not only being knowledgeable, but also being an experienced personality. So that's what is called capacity to learn to acquire knowledge. It's not to learn, it is how to learn is very important. Learning to learn. So that is the next level. So then it improves the competency in using knowledge. And finally, how to interact with others. So ultimate job is to be a social person. So end up being socialized personality. So that's what is called ability to interact with others. So toward this target, it's not that, human beings are good at learning. Human being. No, I learned a lot about how to address master's students, because I'm a teacher. I learned a lot. Now I'm specialized in teaching computer science. So similarly, somebody is specialized in making up a diagnosing a disease of an animal. Somebody is a doctor of a medical doctor diagnosing problems with bones, orthopedician, right? So somebody is good at diagnosing problems in children, pediatrician. So these are all, everybody has a special interest. Everybody is specially trained. That's what I'm talking about. Look at this specially trained concept is not only applicable to human being. Probably, if you look at this picture now, look at here the animals which are called oxes. They are specially trained for cultivation. These oxes are not generally used for riding. These oxes are not generally used for crime detection, right? So these oxes are not generally used for carrying goods, like the way in which we do it with the support of donkeys, So these oxes cannot be used. However, these oxes are used for cultivation, for farming purpose. How is that possible? Because our ancestors have learned a lot, Soon after civilization, the ancestors have felt that instead of myself leading my life, it's good if I can take a support of my family members. It's good if I can take additional support of my good friends. It is good if I can also think of taking up support of animals. Then they thought of catching hold of a couple of animals who could be controlled. And they caught hold of this type of animal like oxes, and they had given them a specialized training so that they can be used for the purpose of farming, cultivation. Look at here, the donkeys are carrying goods, goods. These are the donkeys, and they are specially trained for how to carry goods from one location to another location. Donkeys are known for hardworking. That's what they understood. So donkeys were known for hardworking, so they can be given this task of carrying goods. Look at even today, the police people make use of the support of what? The dogs for detecting, for identifying who must have committed a crime. who must have committed a crime. So that's dogs are known for crime detection, and horses are known for riding. Look at, and horse cannot be used for cultivation. Horse generally are not used, in farming purpose. They are used for riding purpose and so on. I mean, these animals are given specialized training. Animals were also good at learning. Good at learning. I mean, they were conducted. They were given a training. Human being have trained them for a specific, task of interest. So once they have been trained well, those can be used. And while following these operations, horse would learn on themselves, dogs would learn on themselves. So the dogs are employed for 1 or 2 tasks today. Perhaps day after tomorrow, they may not, they may see a different task which the dogs have not come across so far, but still dogs are capable of handling it. So that's what I call it as relearning. So learning, relearning, right? So cognition and recognition. Is very important here. So like a search and a research in case of research philosophy. So these are all some good examples of natural learning. I mean, animals learning. So human being is also an animal. We are all good at natural learning. I mean, we learn by nature. So instead of giving training to these living, animals, the living entities, can we think of giving similar trainings for non-living, artificially made computing system? That is the scenario today. I mean, if I can give a training to oxes, and if I can give a training to donkeys to get them trained well so that they can be deployed for my purpose, why can't I think of giving similar training for my computing system so that computing system can be used as an assisting tool to make my job easier, or to make myself much more efficient, or to make myself better, I mean effective. So can we think of that? Is what is called artificial learning. That's what is called artificial learning. So which result with artificial intelligence. It's not that natural intelligence. It is an intelligence which has got to be inculcated into a computing system, which are a non-living entity, which are artificially made computing system. And such process, or such a field which addresses how to train computers, how to inculcate ability of learning themselves, learning themselves. So it is what is called the area of computer science, area of learning, that's called artificial intelligence. Artificial intelligence is to make computers exhibiting intelligence, right? So by the end of it, I want my computer exhibit certain degree of intelligence, if not fully, at least certain degree of intelligence. Tomorrow I retrain it so that it exhibits some more and some more. After 1 month, perhaps my computer can help me out as if my computer is my personal secretary. So that is what. If I can make my computer exhibit intelligence, then I say it is called artificial intelligence. So programming a computer is one method of inculcating an ability. Today, you go to a computer and then interact with the computer. Computer would answer your question. So then some degree of intelligence was inculcated, and that is what is called a programming of a computer. So a computer has got to be programmed. Even simple programming which mimic human intelligence by a computing technology is called artificial intelligence, algorithmic thinking on the other end. So I give set of numbers to the computer. Let's assume that I give randomly some 1,000 numbers to the computer. Then I expect the computer to arrange them, in sorting, increasing order. So perhaps, at the time of allotting seats for master students, so we go with a computer, and then students would apply the online, they submit their merits, and based on the merit, the computer would rank them, So that is automatic. Such is called sorting. Then I just want to look whether myself is there in the collection or not. That is called searching. So who is the best student? Reasoning out. And then can I plan so that according to the roster and merit, the seats could automatically be allotted, like what is KEA is doing now for allotment of engineering students. It's a planning, right? So all in all, it is an expert system. So that is what is called artificial intelligence. Artificial intelligence, the name itself indicates it is an intelligent created, but not for naturally, not by naturally, but by artificially. It is not for natural human being, not even for natural animal, but it is for non-living object called computer. So that is called artificial intelligence. So earlier, way back, 20 years back, perhaps, if I remember, we used to define computer as a general purpose computing system. I mean, computers were created, computers were manufactured, which could be later on programmed for any purpose. That's called general purpose. But today, we don't say that computers are general purpose. Computers are manufactured for personalized purposes. I mean, I just buy a computer which suits my requirement. You buy a computer which suits your requirement. I mean, for everybody, depending on your requirement, computer could now be personalized. Okay, the computer which is serving my purpose, orthopedic. Let's assume that I'm an orthopedician. I have a computer with a software tool which can be used only for decision making on X-rays, right? On MR images, right? So, but that cannot be used for a different purpose of biometric. If there is a computer which can be used for fingerprint analysis, cannot be used for X-ray analytics and so on. So I say that in that sense, today's computers are no longer general purpose, but they are more personalized computing entity because of this AI, artificial intelligence. How do I achieve this artificial intelligence? One of the approaches, right? So one of the approaches is what is called machine learning. I mean, can I allow the system to learn on its own? Looking at myself, talking continuously for about 1 hour. I keep my camera on. Then Dr. Nanjan Swami got myself introduced to you people, and computer has heard of his voice also. Then Dr. Nanjan Swami said, it is the person who has now logged into our system, Professor Guru. And suddenly my camera got opened. Look at, the computer has to capture my image, capture my face image, and also has to capture the audio signal of Dr. Nanjan Swami and has to correlate them, so that computer should finally understand that this is how Dr. Guru looks. This is how the face of the Dr. Guru. So then computer has learned today, right? Look at myself not introduced, not introduced myself to you people, telling that I am Dr. Guru. Suddenly I just have logged into the system and my video got operated and my images were made available, right? My face images were made available. Parallelly, Dr. Nanjan Swami was talking from the other end, telling that, so Dr. Guru has logged in. Then system has to pick these two: voice audio from Dr. Nanjan Swami's computer and a video from my computer, and the system server has to integrate them together and finally say that this is how the picture of Dr. Guru. And tomorrow, in case when Dr. Nanjan Swami keeps this system open so that I logged in for listening of somebody's lecture, let's call it as a lecture on research methodology, you all also log in. I myself log in. The moment I log in, it should tell that, hello, Dr. Guru, how are you? The computer automatically should recognize me tomorrow. So today, what is it doing? It is integrating Dr. Nanjan Swami's voice, Dr. Guru, with my image. That is called a cognition. That's called learning, right? And tomorrow, when I simply logged in, looking at my video, the computer should automatically generate a voice message stating that, hello, Dr. Guru, good morning. So then tomorrow, what is happening is a recognition. It is recognition. Recognition means recognition. It is again learning about myself. And that approach is what is called machine learning, right? Learning to learn, right? Automatic. Mechanization of the process of learning is what is called machine learning. Mechanization, automation. So mechanization of process of learning, the way in which I pick up knowledge, I expect computer also to pick up the knowledge, and that automation is what is called machine learning. So these machine learnings were called, these were earlier, machine learning was called by different terminologies like pattern classification, pattern clustering, and so on and so forth. So there is some picture on the right top corner of the slide. Perhaps I would explain that in a little later stage. So let's understand. So as I said earlier, there were computers which are called general purpose computing system, and later on now they are called personalized. No longer they are no personalized, they are specialized today. Is exactly like, somebody attend through the school, during schooling, we learn a lot, we learn various subjects, social sciences, mathematics, languages, actual sciences, physical sciences. We learn a lot, we learn various. And then as we move upward, we become narrow down, like, in undergraduate, we are personalized. In masters, we become specialized. So similarly here, so at the base level, general purpose computing, at the next middle level, a personalized computing, at the highest possible level today, they are more specialized. I mean, today we are talking about computers which are specially used for internet connectivity, and that computer knows only that. And computers known for only teaching. Computers known for controlling only, satellites. Computers are only for controlling robots. So that's are called specialized computing system. So this machine learning made today the possibility of specializing a computing system by giving them a specialized training. That is what is called a specialized computing technology today. So computers should learn them. Computers should learn for what? To acquire knowledge and skill. So, and that is what is called machine learning. That's what I made it. Let's have some examples now. Okay, look at here. Here is an example. I have not stated anything. So this is a pattern data set. I have some example images for you. So there are about 3 rows, and 4 columns. Totally, I have got about 12 different pictures. Now my question is to look at these images and understand the way in which you want to pursue them. Perhaps one of you may understand that the first one looks like a library, right? The second one looks like a Nokia, advertisement. The third one looks like a food product, pickle, box, pickle box. And the fourth one is also food item, right? The fifth one, the first in the second row, appears to be, something like advertisement. The next one is a food item. I mean, if you go on observing individually, you end up observing that, there are certain images which represent food items. There are images which represent, advertisement, and there are certain pictures which represent, libraries, and so on and so forth, right? Okay, so that's what I say. You learn yourself. You are not given any explanation, right? You are just given these examples. I mean, look at in a simple way. If I tell you, probably you can understand that. I have a computer. I want to program a computer. I just write a program so that computer is capable of attending my problem of what? Checking whether a given number is a prime number or not. Very simple problem. One number I give. So the number could be 7. Then you say it is a prime. If I give 12, then you say it's not a prime. If you can say, I want my computer, then I sit and write a program so that program becomes capable of classifying a number either as a prime number nor as a non-prime number, right? So then how do you do that? It is an explicit programming. When the moment it is programmed, the computer is so good now. Given any number, computer can answer whether it is a prime number or not a prime. So it is explicit programming. If I do so, then I say it is artificial intelligence in general. Computer has some intelligence, to classify a number either as a prime or not a prime. So then it is exhibiting certain degree of intelligence in at least that for that problem. So that is called artificial intelligence in general. Instead of programming it, what do? I just give some examples of prime numbers. I mean, I say 3, I say 7, I say 19, I say 71. I just randomly pick some examples, 100 examples of some numbers which are prime. I know that they are one class. And I randomly pick another numbers which are not prime, like, 6, 9, 20, 100, 1000, 1024. I pick some numbers which are non-prime. Here are some 100 examples of prime numbers. Here are the 100 examples of non-prime numbers. I have 2 subsets of numbers. Then what do? I give to the computer both the subsets, telling that this is one class, this is another class of numbers. So computer is expected to read them individually and understand how are these similar, and how are these two dissimilar, right? If computer on its own understand how to classify these 2 classes of numbers, how to discriminate these 2 classes of or subclasses of numbers, then I say that computer exhibiting not only acquiring knowledge, the process of acquiring knowledge. I mean, learning to learn. So then automatically it learns and then programs itself. And such a self-programming, such an ability to acquire knowledge to program itself is what is called machine learning, right? So explicit programming is one way of making computers intelligent. Another one, I don't do explicit programming. No, nothing doing. I just give examples of my interest. Looking at the examples of my interest, the system should automatically understand my requirement. Then I say it is machine learning. Similarly, here I have some example images. I don't explain what are these, but computer has to classify them. Computer has to group them automatically. Perhaps when you group them, you may end up grouping into three. One is, as I said, library pictures. Another one, as I said, food items. What at another I say advertisement. There are three different varieties. Three varieties of image examples I have. So hence I say that. So this is what I learned. Finally, I end up learning that out of all 12, I can group them into three categories of images. This is what is called learning, right? If this could be automated, then I want computer to read these images. I want computer to have a camera setup. If I can see and do something, why not computer with the support of a camera? Those use cases are computer vision use cases, video analytics, image processing. You must have heard of all these, So these are examples of video analytics. Look at here. Probably now I want you to observe there are about 4 plus 4 plus 3, 11 individual images, right? Put together. I want you to understand how many varieties of images you see here. Then I'm sure that every one of you got your own way of understanding. So there are 2 images which represent, the apples. So then there are 2 fruit images, right? Apple images. And the remaining are all human being. Fine. So then you may end up with 2 groups. You may end up with 2 groups. One is images of human being and images of non-human being called apples, right? You end up understanding 2 categories of images. That's one way. Another one of you could understand that, amongst these human beings, there are ladies and gents. There are females and males. Then I do what? Subclasses. Male class, female class, and a fruit class. There are 3 groups there. Okay. So there are 3 groups. This is also another way of understanding, So I group all the men together. And then I group all women together, and then I group 2 apple images together. Then there are 3 classes or 3 categories. I mean, this corpus of 11 images, corpus means collection. This collection of 11 images has been decomposed into 3 subgroups, where in each group there are likelihood images. So these are all men, these are all women, these are all apple. I want computer to do this. If I want computer to do that, I have to develop algorithmic model and I have to program it, right? Whatever I do, but finally I want computer to do like this. If I make it computer capable of doing like this, then I say computer has some intelligence in classifying images, right? Okay, categorizing images, and that is what is called machine learning. So instead of this way of understanding, so somebody can understand this way also. No, I don't go for grouping of based on genders. Instead, I go for a grouping of based on their professionalism. I mean, look, all in first top 3 men and 2 women. They're all politicians. They're all politicians. Whereas the next group, there are 4 examples belonging to what is called cinema industries, film industries, and still there are 2 images of apple food item, right? This is alternative way. One based on gender, another one based on their professional, right? These are all actors. Those are all politicians. What they do every day, right? I mean, for understanding, ultimate job is to understanding of a picture or understanding of an object of interest. Ultimate job is to characterize it. How will I characterize it? While characterizing an object of your interest, you have to keep in mind what is your purpose of interest. Finally, tomorrow, would you like to recognize Honorable Prime Minister Modi ji as a man or a politician? If you want him to be recognized tomorrow just as a male class, then you go with this way of understanding, right? Okay. But the moment you see the picture of Sonia Gandhi, if you want to say that she's a lady, then you go with this class. If you want to say that she is a politician, then go for this way of grouping of items. So this is, purpose matters. How do I characterize? Characterization is a process of acquiring knowledge with respect to some attributes. Acquiring knowledge with respect to some characteristic features. What features I get to look at? Okay. So you just extract such features and keep them in the repository as a library of knowledge. And the moment you go for relearning, I mean recognition, then do the same thing, match it against, and then say what it is, right? This is how I do that. So somebody must have learned, no, I don't want to learn either into these three types or into these three types, like, gender and then a fruit or something. But I want to learn, like, one is male politician, male actors, another one is female politician, another one is female actress, and then a fruit. There are 5 ways, 5 groups. So look at, there are 3 possibilities of grouping. One is this, another one is this, yet another is this. So which is the best way? Ultimately, you have got to decide. You have got to decide. What is your purpose? Do you really want to simply say only politician, or you want to say male politician, female actress, right? If you want to say like that, then probably I would rather recommend you go with these 5 subclasses. I mean, this is what is called learning. You are learning without getting any data from a trainer. I am a trainer. I just give only examples to you and allow you to learn. Trainer will never help you out at all. So teacher, I'm a teacher. I'm giving examples to you. So you are learning without my support. And such a learning without teacher support is what is called unsupervised learning. I mean, basically in machine learning, we have 2 fundamental ways of learning. One is unsupervised learning. There is nothing like a teacher who supervises your learning process. Similarly, computer will learn all on itself by taking some examples, and nothing is stated about the examples. So that's what is called unsupervised. So once you learn that, these are the 5 different classes. Or I myself give you, look, I am talking about dear friends, dear colleagues, I'm talking about these 5 groups, 5 groups. One is a male politician, another one is a male actor, etc., etc. There are 5 classes I'm talking about. Now, I'm sorry that this is a new picture. The one which you see at the bottom left, So it is a new picture. What it is? Where does it go? Does it go to the class 1? Does it go to the class 2? Does it become a member of a class 3? Where does it go? Then perhaps those who are familiar with this picture, you would classify that as not a member of the first one, not even a member of the second one, but a member of the third one, lady politician, right? So that is what is called subsequent task. So you have to learn with certain finite example, but learning has got to be generalized. Please try to understand that. So is as good as a teacher of mathematics would solve 10 examples in the class, making students capable of solving additionally some more also. I mean, in the examination, if 11th example is given, 11th problem is given, which was not attended by the teacher in the classroom, but still student is capable of solving that problem. And that's what is called generalization. In machine learning, we have to generalize. So we have only finitely many samples for training the computer. But at the time of deployment of the computer, you may have something new which was not taken into account at the time of training. In spite of it, I want computers correctly understanding it, correctly labeling it, and coming out with the actual expected decision without getting into any failure. So that is what is called generalization ability. So here, this Indira Gandhi's photo is given as a new one. Still, the system has to say that it is a lady, number 1. Number 2, it is a politician, right? So that's what is called classification problem. So it is unsupervised learning helped us in making them into number of clusters, 5 clusters. And then finally, one photo of new photo is given. Then you have to classify where does it go. So let's have another example here. These are the 5 another different classes. One is orange group, another one is a group of Mysore pox, pieces of Mysore pox, groups of elephants, and capsicum, vegetable, and then pictures of men and so on, right? This is directly I had given you 5 classes. You need not have to group them. All examples are themselves grouped, depending on their likelihood, depending on their similarity. Please let me underline the term called similarity. So orange looks similar to another orange. Orange looks dissimilar from an elephant. Elephant looks similar to another elephant. An elephant looks dissimilar from a picture of a man, right? So this is how, I mean, based on their likelihoodness, based on their similarities, I mean, you just have made groups and groups themselves are given to you, then I say that it's not that I have given you the example samples, but I also given you the labels of the samples. Then I say your learning is supervised. There is a teacher like me helping you to learn, right? I say there are 5 groups, learn them. So then your task is to extract certain characteristics from the class 1 and extract certain characteristics from the class 2 and see how are these characteristics different from class 1 to class 2, and how are these characteristics are similar from the, for the examples of the same class. So you have to acquire such knowledge which help you to look at these similar and which would help you to look at these two dissimilar, right? So and that's what is called supervised learning. Then later I give this photography. If I give this photography, then you should say that, oh, it doesn't belong to the orange class. It does not even belong to the elephant class, but it belongs to the men class. How do you do that? If I can do manually, why not my computer, right? Automation of the way in which you accomplish this task of labeling an unknown example, unknown photography with the support of known labels, known classes is, right, what is called building up artificial intelligence, right, through automation of learning process. Computers are expected to learn themselves. That's called machine learning. Hope I made the definition of machine learning at least very catchy and interesting for the people who are not from computer science background. This is what is called supervised learning. So process of assigning labels to unknown objects which were not given at the time of training. So far up to here it is a training. Up to here is a training. After training, I give a new example, unseen example. Then you are going to make use of your training, classify it. That's what is called supervised learning. So look at one more example. I want to learn about these objects. A is an object for me. B is an object. Then I look at one by one, as good as, imagine there is a kid studying in a lower kindergarten, LKG or UKG, and teacher started teaching the kid upper cases of English alphabet. Then first day lecture, first day in the school, they teach only A, how to write A, how to write A. Tomorrow kid has to recognize that. The moment teacher writes A on the board, kid has to recognize it. Then kid will learn A today. B will be taught tomorrow. C will be taught additionally on the next day. Let's assume that there are about a week program where there are 6 days. Monday A is taught, Tuesday B is introduced, Wednesday C is introduced, next D is introduced, and so on. Now question is to understand, how does kid learn about these, right? So then on Monday, kid learns, oh, look at A, then understand that there is some hole in between, there is a hole in the middle. So that there is a gap, making a triangle. Kid cannot understand it is a triangle, but I'm explaining you that there is a hole. Oh, there is some hole in it. That's what is called A. When Tuesday, B is introduced, B is introduced by the teacher, kid will compare it against A. And how is that different from yesterday example? So kid, actually, we don't want to describe it, but we want to remember it. And how is that different from other, right? If I can remember only such ability of discrimination, perhaps I become good at recognizing. Then now on Tuesday, kid understand that, oh, here are 2 holes instead of single hole. In case of A, instead of single hole, in B, there are 2 holes. There are 2 holes in the picture. So C. On Wednesday, C is introduced. Then kid understand that it has no hole at all. It is an open, right? It's an open. When D is introduced, then kid gets confused. When D is introduced, kid gets confused because D still has a single hole where A also had a single hole. Then it gets confused. Then it changes its learning now. Whatever it wanted to learn based on holes, but unfortunately on 4th day, that method of learning or that features called hole, number of holes in that, would fail in discriminating A from A, A from D, because both of them have got a single hole. Then kid has a confusion. So to resolve that confusion, perhaps kid will understand that, oh, look at, in the case of A, there are slant lines and there is one horizontal line. Whereas in case of D, there is one vertical line and there is a C-like but in reverse. So C is right open, whereas D, if I forget the vertical, then left open, right? Semicircles are also there. So I learn like that. Then when I move on to E, then I understand that earlier, like in case of D, there is a vertical line. But in addition to that, here, instead of having a open curve, we have 3 horizontal lines. Whereas in case of F, we have only 2 horizontal lines. So this is how I describe. Look, my interest is not to describe these objects fully. However, my interest is to somehow remember what attributes of this, what characteristics of these make them different from others, make them unique when compared to others. So there are about 26 characters we have to learn about. So look at, so then what I do, basically I create feature set. I create feature set. And that feature set could be lines and curve segments in this. Then look at, I have vertical line, I have horizontal line, I have 45-degree line, I have minus 45-degree line, slant lines. That's how the kids are initially trained how to write horizontal. They call it a sleeping line. They call it a standing line, right? They call it a slant line, left slant, right. Look, kids are first introduced to these varieties of lines, and then kids are introduced to these varieties of curves, right open, left open, bottom open, top open, and so on and so forth. And later on, each character like A, B, C, D, E, F, etc. are described by these segments. These segments. How is that? Then let's assume that. Look at the object A. Object A has one line segment of 0 degree. Top indicates attribute. I mean 0 degree line, right? 0 indicates horizontal line, 0 degree line. So 45 indicates one inclined line with an angle of 45-degree line. So 90 indicates a vertical line. 145 indicates minus 45, right? Minus 45. So top semicircle is a bottom open. Bottom semicircle is a top open. Left semicircle is a like C. So right semicircle. So now I am trying to describe these objects A, B, C, D, F in terms of these attributes. These are called characteristics. These are called features. 4 line segments, 4 semicircles are called features. So every object A, B, C, D is being described by or explained by or represented by these 8 attributes. So look, in case of A, there is one horizontal line. That is what is number 1 there. Please understand. Here is number 1 indicates there is one horizontal line in A. Here is 1 indicate there is one 45-degree line in A. And here 90-degree vertical line is missing, 0. There is no vertical line at all. And minus 45-degree. So minus 45-degree. So there is one. This right slant line is a minus 45-degree. And there is nothing like top semi, bottom semi, left semi, right semi circles. They are all 0. They are 0 in number. On the other hand, if you go to B, we have one vertical line, I mean 90-degree, there is one. And we have 2 left open, I mean right semicircle. So there are 2 right semicircle here, and rest of them are all absent. On C, it is only left semicircle, 1 in number, and rest of them are all zeros absent. And then D, 1 vertical and 1 right semicircle, 1 vertical 90-degree and 1 right semicircle, and rest of them are all 0. E, there are 3 horizontal 0-degree line, 3, and there is 1 vertical line here 90-degree, and rest of them are all 0. F, in case of F, there are 2 instead of 3 like E, it is 2 horizontal line and 1 vertical line, and rest of, look at, I just have created this knowledge base. I just have created this matrix on the other end. If you know high school mathematics, it is a matrix of integers. It's a matrix of integer, has got 6 rows and has got 8 columns. So this 1 1 0 1 0 0 0 0 is a description on A. I mean, every object, every scene, every pattern, the moment it is learned by a computer, it will not be saved as it is. It will be saved in the form of numbers. I mean, everything will be converted into numbers. So if you feel that there is a biometric system which recognizes all employees of your college, then your image, your photography is not saved as photography. Your image is saved as only the set of numbers. So I'm going to convert any object of your interest into set of numbers. Once you converted them into set of numbers, see that the set of numbers representing my face and set of numbers representing your face should be totally different, right? should be totally different. They should not be identical. And the photographies of mine tomorrow you are collecting, should have the same set of numbers, at least similar set of numbers, right? Set of similar numbers. So that matching can be established. So ultimate job is to convert any example of your interest, any object of your interest into set of numbers. So look, this A is now represented by 8 values: 1 1 0 1 0 0 0 0. These 8 values together. Look at these string. These 8 values are different from those 8 values of B, and these 8 values of B are different from those 8 values of C, and so on and so on. I mean, no two of these rows, no two of them look identical. Hence, I can discriminate them. Tomorrow, I come out with one example of A. Again, I do the same, match it against, right? I convert that into. So look at here is an example of generalization now. Then cognition starts. When cognition starts, I give this set pattern, test pattern. Perhaps looking at these objects you have learned, right? Though it is not exactly A, I'm sure that the human brain, with this limited knowledge of 6 characters, with this limited knowledge of 6 objects, tomorrow if you are asked to classify this, I'm sure that you end up classifying like A. You don't say it's a cap symbol, it is a A, because I wanted you to label it by one of those 6 only. It cannot be, it cannot be F, it cannot be D, it cannot be C, but it is looking like A, more similar to A rather than being similar to any other. Then how do I do that? I just go for creating similar row for that, right? I just go for creating similar row for it. So there is 145, 1 minus 45, and rest of them are all 0. When you take up this 8 values, 0 1 0 1 0 0 0 0, then you have got to match it against these, match it against 1 1 0. Then look at how many matches are there. Then with A, it matches with, except the first one, except the first one, whereas here you have a 0 and rest of them match with respect to D, with respect to F, etc. But it has got a highest match with A and highest mismatch with the remaining. So then my decision would go towards A. Look at, with A, the difference is only with respect to one property, but with C, the difference is with respect to 3 properties. And similarly, which is with a less distance, with a lesser difference, with A, it has a less difference. With the differentiation I am talking about, matching high score or differentiation should be low score. So here I have used Euclidean distance as a formula to compute this. I mean, you use the Euclidean Pythagorean extended formula to match this, vector of 8 values against the vector of, I mean, finally, how is that stored? This cap is stored in the form of vector of 8 values. And A was stored in the form of vector of 8 value. B, I mean, there were basically in my library of knowledge, there are 6 vectors, A, B, C, D, F. There are correspondingly 6 vectors. Now the 7th vector comes in. Now, which of these 6 vectors is very close to it in a 8-dimensional space? So use the Euclidean formula and try to find out the closest one. And that closest one is what is A, with a close rank 1, right? That is what is called arithmetic, right? So artificial intelligence, as I said, is a process of inculcating the ability of solving a problem through an explicit programming, whereas machine learning is one of the ways to achieve artificial intelligence. And today we are talking about deep learning. You may be familiar, may not be familiar, but today we are talking about deep learning. Look at, learning is a superficial level. Deep learning is a deeper way of understanding, right? Like somebody is doing research on the topic of interest. Similarly, today we have deep learning architectures which learn the objects very deeply, right? By integrating the knowledge, features, right? And that becomes a powerful teacher. Why I'm saying that it's a powerful teacher? Because today, because of deep learning, field, machine learning is possible, is being attained. So hence deep learning is called a powerful teacher. to make systems learn. So look at here, machine learning and deep learning, the difference. So machine learning, what I explained here, I decided about these features. Oh, this is good to go with these 8 features and then describe the objects. I don't want to do that. I want system to do it automatically. I mean, feature engineering is in my hand in case of classical machine learning. And then I go for classification and training the model and then make the system ready. Whereas, I mean, car is to be learned, then I sit and tell the system, look at these features. There are 4 wheels, there are 4 windows, there is a major 1 window in front, there is a major 1 window in the back. This is how the shape of the car. If I explicitly explain, then I say it is a classical machine learning. I participate, I intervene in deciding which are the best features to be extracted. That is called classical machine learning. Whereas that is not necessarily to be explicitly stated, but let the system look at the examples and then decide automatically. That is what is called deep learning. So then system has to understand in a deeper way. So that's what is deep learning. We have today a gallery of deep learning architectures, and because of existence of varieties of deep learning architectures, today we enjoy making machine learning tasks possible, right, in reality. So these are the basic steps. There are 4 steps of machine learning. I mean, if you want to set up a machine learning environment, then you have to talk about these, four components. One is sample space. What are your examples? For example, in my case, I have got A, B, C, D, E, F, or I have got photos of these 11 people, right? So these are the 1 photo, 2nd photo, 3rd photo. This is how one writes A. This is how another one writes A. I mean, go with collecting different handwritings of 100 people. How do they write A? Right? 100 people, how do they write B? So take 100 samples of A, 100 samples of B, 100 samples of C, 100 samples, etc. And each is of 100 samples. I want to train a computer for A, B, C, D, E, F, 6 objects. Then 100 into 6, 600 examples I have. Right? And that is what is called sample space. Collection of all possible samples of each example. So that's what is called sample space. Now, out of these 600, first 100 are called A, next 100 are called B, next 100 are called C, etc. These are labels. I have 6 labels. First 100 are mapped onto 1, next 100 are mapped onto B, next 100 are mapped onto C. So these are the 6 labels. This is a label class, I mean label space. This is a sample space. So I have a mapping between these 2. So I get to have a mapping between these. That talks about the distribution. Right? That talks about the distribution. So there is a correspondence between this space X and the space Y. There is a distribution. Learning of this distribution by a computer, mechanization of learning of this mapping by a computer is what is called machine learning. And the other way around, if I put it from mathematics point of view, then machine learning is nothing other than understanding what is this distribution, how is the distribution, is there any hypothesis which best fits this distribution. Predicting such an hypothesis is a problem of machine learning. So while predicting that hypothesis, after prediction, this is what is actual distribution I'm talking about. But I predict something. When I predict something, instead of 100 A samples getting classified as A, 80 will be classified as A and 20 will be classified as, let's say, D, because of single over. Amongst 100 examples of B, 90 will be classified correctly as B, and remaining 10 would go as C, let's assume. And some of them get misclassified. Then what is that loss? What is that loss? I mean, what is the misclassification? How many are successful? How many are not successful? So that is what is called loss function. The job of a machine learning task is to predict this distribution, predict best hypothesis, so that this loss function L will be minimized. That is, it is good if this L would be 0, but it should be as minimum as possible. That is what is. To quickly pass through it, the task is, as I said, given are some examples in X cross Y correspondence, predicting H which minimizing L. H is an hypothesis. And that is what, I mean, mapping is a H. I have a space, I got to search for that. So possibly the mapping could be many. So then I got to search. This is the possible space where I got to search for such an hypothesis. This is HG is the ground truth, expected ground truth. This is where it is present. This is where it is present. But unfortunately, my search space may not be of as huge as is expected, maybe only this smaller boundary, right? So then I am looking for a solution within this. Unfortunately, expected solution is outside that. Obviously, there is an error. Then this is what is expected at least in this space, but this is what is not matching against the ground. That's an error. So that is what is called one type of error. So this is a computed H. Unfortunately, computer computes this. That is another type of error. But this is what is more optimal solution. But that is not computed by the computer. Then there is an error. These are the three different types of error. Approximation error, right? Which we are going to minimize, right? Which we are going to overfitting error, underfitting error. These are also are got to be minimized. These are the three different types of errors which we are going to minimize with the support of loss function. So predicting the best H hypothesis which suits this mapping so that loss function will lead to a minimum value is what is called a machine learning task. So if I just explain with some, pictorial example, look, I have got a camera, I capture, ultimate job is to, classify, flora and fauna. Let's assume that there are many flies and there are many flowers. So which flies will go and sit on which flower? I got to associate them. I have a beautiful garden of 100 acres. Varieties of trees, varieties of flowers, varieties of leaves are available, and many flies are coming in. They enjoy their life here, right? So in Ranganatittu, Srirangapattanam, there are different varieties of trees, varieties of plants, and varieties of birds coming in. Now my question is to understand what variety of bird sits on what class of plant. What likes what is a question. Can I think of? So fix up a camera, see that the camera would recognize varieties of plant, and as and when birds coming in, bird category has got to be recognized, and then it has to locate which tree on which it sits. Then it has to associate this tree is liked by this bird, species of bird. That's what I want to learn. Finally, by the end of a day, I got to generate that knowledge. Should appear on the dashboard of my computer. Okay, so that is what is. For example, here are the cameras, they capture the images, and images will be subjected for enhancement of their quality. And I need not have to look at the background fully. I got to look at only the flower of my interest, concentrate only on that interest area. So look at rest of them become dark, completely dark. Only this yellow region is extracted, right? And that is what is called segmentation. So it may not look so attractive, so appealing. Then you have to convert that into more appealing. That's what is called enhancement. Quality should be improvised. So you do enhancement, you do segmentation, and then, as I said, extract the features. If you do it manually, then I say that you are into classical machine learning. If I automate it, then I say that you are into deep learning. So it could be color, it could be D features, it could be texture features, right? And there are varieties of features. You need not worry in my currently. So there are varieties of features you have to look at. Take up all the features. Then do you really require so many features? For example, in case of ABCD, do you really require 8 features? To discriminate this, not necessarily, because look at this top semicircle, look at this bottom semicircle, all are zeros, right? And this column doesn't participate at all in discrimination, whereas this column participates because this has 1, these 3 are zeros, this is 3, 2, this participate. This less participates when compared to this. I mean, this is no way participating. They are identical columns, you can eliminate them. I mean, instead of going with 8, you can go with only 6 by eliminating these 2. So that's what I say, a reduction in number of features. Reduction in number of features. You do reduction in number of features, right? Reduce, that is called dimensionality reduction. Do the reduction. Allow the learning models to learn, right? When you allow the learning models to learn, then let the domain experts. Please understand here. I may be very strong in my technology. I am a computer scientist. I am good at only these steps, but I am not good here. What are these? What species is this? What species of flower is this? How many species of plants I have? How many species of flies I have? I have no knowledge. But if you explain me, in case if you are from the background of botany and zoology, if you are a biological scientist, if you are a life scientist, if you can help me out in labeling of all these, then I say you are the domain experts. You are a domain expert, you help me out in understanding these labels and let me make my computer ready based on your input. Then domain experts have got to participate. If I want to build up a system for orthopedician analyzing the medical images, I cannot do that because I have no knowledge on medical sciences. Then I must have a domain expert from medical science. So orthopedician has to explain me what he wants. Every picture has got to be explained to me so that I've got to be labeled. So that is where I see challenging today to take a problem related to agricultural domain, problem related to flora and fauna, problem related to medical sciences, because we really find lacking in domain expertise. But unfortunately, most of the doctors are not interested in supporting us and giving us, because they are not ready to spend time on this, but they wish to spend time for diagnosing people, meeting with patients, helping them, and so on and so forth. That is where we are really finding difficulty in getting the examples labeled. So you have got to give us the text descriptions of each, labels of each, let the learning model. This is computer. Let the computer learn based on your input and based on these activities. Once it is learned, a database will be created and will be indexed. And there is a big, large example annotation and so on, that corpus is created. And once corpus is created, then you can use it for subsequent tomorrow. So I have a big garden. There are varieties of rose plants, right? Varieties of rose plants. I want to spray some chemicals because the rose plants have been been suffering because of diseases. So day before yesterday, I was looking at the literature of diseases on rose plants. I could identify there were about 21 different diseases based on fungus, based on bacteria. There were about 22 different types of diseases that rose plants may suffer, especially in the region of Karnataka. Then the question is can I think of making a small robo which will walk into the garden of rose garden, and then it will be with a camera setup, as and when it looks at a rose plant, should be able to identify that this rose is suffering or this plant is suffering due to this disease. The moment it understands that this plant is with this type of disease, then it can guide me. Suddenly, doctor, it can send me an SMS stating that, Guru, look at such and such a rose plant, plant number 5 has been infected by this disease. Please take care of spraying of this type of chemical. That's a supporting system, right? So that's what I'm talking about. But what type of disease? There are about 22 varieties of diseases. Unfortunately, I'm not aware of what chemical has got to be sprayed as a medicine for what disease. I need botanical expert. I need a life scientist for that. So that's another challenging issue. And in one case, on the other hand, opportunity for a botanist. So can we think of having mobile cell phone instead of allowing a robot? I being a maintainer of a rose garden, I go with my cell phone, I take a picture of the rose. The moment I take a picture of a rose, then it should say that, oh, this is ready to pluck. You can pick it up. And this is really good, healthy rose. The next one, this is not healthy, right? Okay, it petal has a disease. What type of disease is that? Then I got to spray something on that, right? Then the system has to guide me up. That can I think of such a mobile app today, right? Of course, we are coming out with such mobile apps for banana trees, classification of diseases on banana leaves, then guiding, giving recommendations. These are all possible today. There And for the sake of completeness of my lecture, I just wanted to touch upon there are different learning algorithms. So K-nearest neighbor, we have decision tree ensemble, we have regression modalities, we have support vector mission, right? We have Bayesian learning, we have learning, varieties of learning models. Every learning model has got its own advantages and disadvantages, has got its own ability, right? And not misclassification. So you have to learn. But one thing is certain, everything learns systems in Euclidean space. But in reality, our brain doesn't work in Euclidean space, right? So this is what. But kernel functions or mathematics come into picture to make learning more robust. That's all. Okay, with Euclidean linear spaces, so learning is not that robust. But the moment kernel functions are introduced, then learning becomes much more robust. That's the difference. And today we have different kernel functions, to make learning possible and effective. So let me not get into that mathematics too much. So this is how, once this library of knowledge is created, what you have to do at the time of next day, another fly comes in, then you do the same thing, match it against. Here is a classical learning model, right? Whatever I explained, learning model would look at the corpus, and based on this storage and based on this incoming, the top K retrieval will be given. Or probably this is the first one, probably otherwise this is the second one. Etc. This could be the disease type, or this could be the disease type. Give the ranking and choose the first, the top K, top 3, top 1, and so on and so forth. So can we make this also again on mobile devices? This is challenging today for a computer scientist, Android programmer especially. So deep learning architectures are many. Today we talk about many. So actually, when deep learning started coming, we were happy. Because instead of working with the classical machine learning, which is really tedious job, for a human individual, deep learning architecture started giving us wonderful results. Even today, deep learning architectures give us wonderful results. But unfortunately, there are varieties of deep learning architectures. There are many. It's a gallery of architecture, I would rather say. Because of gallery of deep topologies, unfortunately, I am with a high degree of confusion. Which deep topology works better for my application? I have to do searching again. Which deep architecture is good for my face recognition, good for my fingerprint recognition, good for taking up attendance of my students, right? And so on. So if good for classroom where lighting condition is too bad, classroom where lighting condition is too good, classroom where lighting condition is random, right? Look at that is a problem today. So just because you have got deep learning architecture, you cannot simply say that I got my problem solved, right? Looking for a best deep learning architecture, and no deep learning architecture will get you directly the problem solved. You have to personalize it, you have to tailor it up to suit your requirement. So deep learning requires very voluminous data, right? Because it has to look at the examples. Unless you feed in it with multiple examples, thousands of examples, deep learning cannot learn the mapping. So the mapping learning becomes robust if there are many. I mean, if you want to make somebody good in solving quadratic equations, instead of teaching him one example, teach him 10 examples. Instead of teaching him 10 examples, teach him 100 examples. The moment you introduce more examples of similar type, probably the learning becomes more pakka and robust, right? So that is how the deep learning is. If you want deep learning possible, if you want the deep learning to be possible, you have to have more number of examples, and you should sacrifice computation time. As long as you are ready to provide more time and more examples, then better would be the result. Better would be the success. That's what is called deep learning today. Opportunities, as I said, many. Data quality, I collect. Look at in my laboratory, when we wanted to work on classification of flower species, we collected 127 different flower species. We visited Udakamandalam, visited different flower gardens over there, visited many places in India, and happened to collect pictures of flowers. How many varieties? 127 varieties. And from each variety, we gathered about hundreds of images of each variety. Same variety, hundreds of images from this angle, top angle, bottom angle. When it is bud, when it is middle, and when at the time of harvesting, etc. Different stages of flower, right? Yes, totally. We could gather about 13,000 different pictures. Not all pictures are very clean. Not all pictures are quality-wise good, right? We have to clean it up. We have to prune out. We have to throw out something and keep only wanted, right? Who does it? It is a laborious task. Can that be automated? Is a question number one. If not, then there must be a domain expert. Yes, I captured 127 species, but I was not aware about there were 127 species. Botanist used to help me out. Then there must be a domain expert. Data quantity. How many I should? Why 120 each with hundreds of samples? Why 13,000? Why not 15? Why not only 10,000? What is the problem? I have to understand. Domain experts. Data explainability. Which are the relevant features? Is there any bias? Unwanted? Is there any, what is the confidentiality? Right? So this is really questionable today because of AI-enabled tools in our social life, in market, in bus stand, etc., in airport, data privacy, confidentiality. Let's assume that there is a CBI officer, right? There is a CBI officer. His movement is supposed to be confidential, but he's traveling from Delhi to Bangalore, and he has got some, investigation. Then the moment he travels by air from Delhi to Bangalore, his travel gets recorded. But it's supposed to be confidential. How do I take care of it? And he moves in Bangalore in roads, and there are every residence has a camera today. Look at, really challenging. Data privacy is coming up, another issue in today's AI-enabled solutions. So building trust. Just because I had given you a biometric authentication fingerprint-based system to your school, your college, why do you believe that? Your fingerprint is taken as your attendance only. Why not my attendance? Please think of that. Okay, my face recognition is recognized as me only. My attendance is marked for me only. Who knows? Oh, why should I believe it? So building trust on that system is another important issue. Investment is really costly. I'm not looking for complementary. Please remember, I'm looking for supplementary. This is confusing. And of course, from AI experts, there is a high expectation from public today. So look, problem is on shoulder when it's on my head. When it is on my bottom, it is an opportunity for me. I get to make use of it. So remember, dear friends, in case if you are from computer science background, probably you must have heard of deep learning makes machine learning possible today, and I can do everything. Sorry that most of the tasks do not require deep learning. There is nothing like fully automated tool. All models are not true. All models are not true, though some are really useful. Faithfulness on outcome of AI tool is really important. That is another branch of AI called explainable AI. Let me not get into this too much. Explainable AI is, why does that AI tool takes up such a decision? That has got to be explained. If doctor makes a decision that this man is with lung cancer, why did he decide that that man is infected by lung cancer? What basis he has used to declare that he is supposed to be given a medicine for that? If some patient is declared to be a tuberculosis patient, right? TB has infected him, then what has really helped him? And what basis does he take up such decision? It should be explained. Instead of human being, a doctor takes up a decision. If computer takes up a decision, I want reason for it. So that is what is called explainable AI. Let me not. So during COVID-19, there were great opportunities, especially for my laboratory, my team members, right? Because we were working on face recognition, then suddenly people started coming with masks on their faces. Whatever the face recognition system which we have built up and deployed started misclassifying the faces the moment people started coming with face masks. So we had a wonderful time and challenging issue. We addressed it, in fact. So then we trained different modality, different architectures, and we made them mask detection possible and identifying the mask. and then recognizing people. Look at here, especially recognizing kids. And deploying face recognition for kids is really challenging even today, because the pattern, the growth of that facial pattern is really rate at which the growth is happening on kid face is really high when compared to adult, because our faces has already reached stability, but kid face still has not reached stability. Kid may give a face with some view, but kid may come tomorrow in front of the camera with a mask, looking at a different angle. These are right. Look at here some pictures of myself when I had given my photo for training a computer, maybe the first one neatly looked at. So, but I may come with some beer and added spectacle and so on tomorrow. Still, I expect computer to recognize it is Guru only. Then I may come now because of COVID with a mask. Still, it should say it is Guru only. How to make it? That's what is called it as generalization. So we just have worked on different, way of solving it up. Let me not get into this methods, algorithms, or mathematics of it. So then we have also attended different ways of solving it up and so on. So these are some more use cases, right? What is currently demanding because of online classes is the following. All of you are attending my lecture online, but how do I ensure that you are really attending my lecture? Right? How do I ensure? How does Dr. Nanjit Swami ensure that you are really attending, alert in my lecture? You must have kept your system on, logged in, and must have went off of your room. Still, simply system is there. Then Dr. Nanjit Swami expects you to keep your camera on and see that it is as if it is. Look at the top right. Your video is completely being displayed on the monitor of HRDC Mysore. Then Dr. Nanjit Swami is watching you all individually. Are you present there? Are you listening or and so on? No, I don't want that, because Nanjit Swami is really wasting his time. Instead, can I think of having some app on your computer, app on your mobile, in case if you are attending through mobile, then see the camera gets on and edge computing takes place. I mean, on your system itself, there is a software tool working which captures your videos and then first detect your presence. If you are absent, then it should suddenly send not the video, only the message to Dr. Nanjit Swami system, telling that, so look at so and so is not here in front of me, right? He is absent. If somebody is in front of it, then detect it, and then he must have closed his eyes and started sleeping. Then system should understand that he is not attending. He is still present physically in front of the camera, but unfortunately he is not listening. He is sleeping. That should be. If somebody is unhappy about listening my lecture, then it should send me the information that there is somebody who is really finding it difficult to understand your lecture, so that I can give another example for him. If I am handling classes offline, don't you think that looking at the facial expressions of the students, I would reorient my lecture. I would take up a next example so that he can understand it. Similarly, I want only that. Not me, because I cannot look at all of your videos simultaneously. I want parallel computation take place on your computers. That's what I call it as edge computing. And because of that edge computing, the facial expression should be read and understood, and how many of you are alert, how many of you are finding it difficult, how many of you are not physically present at all. Everything by the end of my 1 hour lecture, that summary has got to be generated. That's what I call it as. It's a computer vision application, online modality, machine learning with AI supported dashboard creation. That's, I call it as AI enabled solution for attendance monitoring. Right? Look at, there are many openings. So this is into some large example of recognizing people in railway station, recognizing people in bus station. Right? Today somebody visits bus station. Then there is a man who is looking after traffic, call it as TC, traffic controller. He sees him and says that, sir, you also came here last week, you traveled to Bangalore. Today also you are traveling Bangalore. Does it mean that you travel every week? He will ask me a question. First day he sees me, he doesn't bother. When I come on the next Monday, then he asks me a question. Sir, good morning. I had seen you last week. You are coming again. Are you traveling every week once? He will put me a question. Look at, can I make such a camera system in bus station? Very large collection, right? In a day, there are lakhs of people coming in, going out. How do I remember how to make computer handling such a big data, right? That is really a bottleneck and a serious problem today. So that's all for computer scientists. Perhaps I can say that indexing, clustering, whatnot, etc. and so on. This is one interesting example which you have solved, which we have worked on, especially during first time COVID, first wave of COVID. So social distancing violation and so on. Look at, this is a drone camera video of Bangalore city, right? We have taken this video by drone camera with the permission of Bangalore police people. And look at, there are trucks detected, cars detected, and people were detected, and the distance between two people going together will be calculated. If the distance is less than 3 feet, 1 meter, look at, image distance is different, natural distance is different. Mapping them is really a challenging task here, right? And nobody is there, no social distance violation, right? If there are any two people coming together close to each other, then it displays. Look at the top left here. Here, there is a violation of social distance. Message will appear in case if there is a violation. Otherwise, no. See? Yeah. So there are people moving here, violating social distance violation. No, social distance violation. Otherwise, no. This is what is machine learning. Right? Drone camera is allowed to fly through, and while flying through, capture signals, and that video signals will be looked at and by detecting people and then calculating the distance. Internally, computer will send an alarm that, look, and such area of Bangalore, people are violating social distance. They are moving together, right? This is what is called machine learning for drone applications. Okay. So this is to detect crowd, whether people go together, are they really well far away, etc. Crowd detected. Look at crowd dispersed, crowd detected, the crowd dispersed. So there are people moving together, crowd detected, right? Dispersed. This is a complete automation. What I am showing, some of the use cases which myself and my research scholars, with the support of data scientists, handled this in 2020, last 2 years back. So when COVID situation started disturbing us, okay. So cough detection, somebody is, this was a real serious problem in COVID first wave, right? Okay. I also worked on X-ray images detection of COVID-19, looking at X-rays, right? We have published a wonderful paper on this in 2020. So other challenges, many classroom attendance taking. So instead of you record the attendance of every student and you are spending 10 minutes for it, out of 45 minutes dedicated or 1 hour dedicated, why? You can think of two cameras in the classroom, as if you are observing through two eyes. There are two cameras, capture the image, and then automatically you let the system record the attendance of students. You need not waste the time. You just spend all 60 minutes to deliver lecture. Okay. So this is activity. Look at first top left image is an entry activity. Person is coming into the shop. What you see in the background is a road. Here, persons are exiting the shop, going out of the shop. These are called entry activity, exit activity. Can I differentiate it? So there is a camera inside the shop. Then camera has to understand that people are going in or person is coming in. If person is coming in, who is that? Is a royal customer to the shop. If royal customer, then it should give an instruction to the owner. So look, so and so, the district commissioner of Mysore city is entering your office. The superintendent of police is coming into your office. Then you just receive him, welcome him, and so on. I want that. Okay. So entry detection, activity detection, and so on. This is another video. I just want you to watch. Is about 30 seconds, roughly about 25-second video. Look at, the people are playing shuttle badminton, and here is a man, myself, standing. Look at, unfortunately, suddenly they fell down, and people made a group, crowd. suddenly. See, for example, here. See, fault detected. You can see this here is a fault detected. Suddenly it appears. Fault detected. I mean, system should understand that. The moment he just slipped down, then fault detected. Fault detected. This is what is called machine learning, right? So this is into something like this man wants to disturb these people. Sorry, I will go with the next. Yeah. See, this is another example where you see somebody disturbing people playing shuttle badminton. So hiding the camera. Look, this gentleman is disturbing them not to play. So then it should send a signal to the owner of this sports pavilion stating that you allowed somebody who is not playing but disturbing others. Okay, so these are the some use cases. So this is a safety zone where construction work is going on, but people have to walk in with safety, jackets and helmets, etc. If somebody is into dangerous environment, then there must be an information. It's about 1 minute video. Please watch it. Look at here. Dangerous, danger. This is a danger zone. People should not enter. When somebody is there, then it should generate an alarm automatically. So it extended to this problem, right? If somebody goes without helmet into this area, then system should call him by name, say that you are not with a helmet, please wear the helmet, otherwise you walk out. If somebody goes without this jacket, the safety jacket, yellow color, you see that safety jacket, because it's a dangerous environment, he has to go with a safety jacket. If somebody goes without safety jacket, or if somebody removes the safety jacket in the environment, then camera should monitor. Is as good as there is an engineer, there is a maestri, somebody who is taking care of that construction process should continuously monitor the people from morning to evening. That could be avoided if you make your computer camera intelligent, right? This is another application into personal protective equipment detection. Yeah, this is a real interesting one for you. I appreciate you concentrate here somebody with a blue colored dress. Please, here you watch this man. You watch this man. He's climbing up. He's climbing up. This is a real image. This is a real video. Unfortunate. This happened in real environment. This was a real video. Suddenly people came closer to him and then took care of his. But unfortunately, sometimes what happens, this man alone was working. Man alone working. Nobody was there. Let's assume that nobody is there in the surrounding. But on Sunday, because he wanted to use his over duty, so he is serving. But unfortunately, he slips down. Then he falls down. The moment he falls down, who will look after? Then let there be a camera watching him continuously. Not to see that he falls down, but instead instructing him. If had there been somebody who was watching him climbing up, perhaps had some other senior engineer was there while he was climbing up, he must have instructed him, be careful. That's what I want computer to do that. Thank God he fell on this surface, but not on this object. Had he fallen on this, perhaps he would have died, right? Look at, he must have been given an instruction by somebody. Please be careful. Can I think of making computers intelligent with a camera setup so that if camera sees somebody climbing up, it has to give him a warning message, right? That is what is machine learning applications. This is the traffic of Bangalore city, right? Look at, there are many violations of traffic rule here. In fact, this lane, this lane is only for heavy vehicle like buses and lorries, but unfortunately two-wheelers and cars are driven here, and these cars and two-wheelers must be given a notice by the RTO because they are violating the rule. If RTO wants to give a notice to these people, then car number has to be recognized. This car number has got to be recognized automatically. Let there be a camera which captures this and finding out who violates it. The moment it sees some car violating the rule, it should recognize the number plate of the car, and automatically email has got to be sent to the owner of the car telling that on such and such a day at such and such a time instance, either you or your driver violated the traffic rule. Can we do that? And that calls upon what is called automatic number plate recognition. Look at here, you see numbers are getting recognized. Can you see here something in white? Something in white here. That is what is the number recognized from this plate. Here KA03 etc. It is here the number. So this is number plate recognition system, right? Number plate recognition, automation of vehicle number plate recognition system. So this is what use case which we have solved and supported Bangalore City Police Department. So this is another application which we work for international project, where there is a safety. Look at here. I think let me explain. So this is supposed to be this is the airport area, and these are the gates where trucks can enter, and there are two possible gates. Here you see barricade, blue colored. These are the gates, and before trucks enters, the truck person has to take a permission from the security guard here, and because it takes some time, 1 minute or few seconds, so truck has to stop and go. When truck stops, the next truck has to stop. Then obviously over a period of time the queue of trucks get formed. Then the problem is to know how long there was a queue of 10 trucks, right? How many trucks were there in the morning at 10 o'clock in the queue? I just want to know. By the end of a day, I want that statistics. I don't want this video to be displayed on my office on a big screen so that I monitor continuously. Instead, by the end of a day, the moment I press a button, I want on the dashboard of my computer, the statistics to be inferred and displayed. That is what is called AI-enabled solution for truck monitoring, right? And the interesting problem here is detecting the truck. Detecting the truck. Let me run this video. This video is about 3 minutes. Please watch this video. Look, trucks are moving.
Sir, it's 12:05, sir.
Yeah, I know.
Yes,
yeah.
yes.
Another 2 minutes, 3 minutes. I'll stop it. So look at, there are trucks moving here. The trucks have got to be recognized. Trucks have got, but look at only those trucks which are running into, which are trying to get into this zone have got to be detected. Not any other truck on the scene. That's challenging problem. Right? Look, this truck is moving, but that should not be detected because it is moving towards another lane. Only those trucks on this lane have got to be detected. This bus should not be detected. This car should not be detected. Look at another heavy truck is coming in. That doesn't get detected because it is moving on a different lane. This is a problem. If you just simply employ a deep architecture for vehicle detection, it detects all the vehicles in the scene. Then how to tailor it up? That is a problem today for computer scientists, right? Okay. So this is how it goes, it goes. Then, and then look at, there are two vehicle and there are four vehicles in the queue. There are 4 vehicles in the queue at this time junction. This is how you have to. Finally, what I want a dashboard with this information. By the end of a day, I want this. What you see on the right bottom, that should be the information shared with the owner of the, but not the video. Video should be there in the real time. But how to capture, how to handle it when it is running, when raining, when it is a sunny day, when it is a raining day, if it is a winter, in the morning, in the evening, climate changes, still camera has to work. How to make? That's really a challenging opportunities for technocrats to solve and tackle. And what is the commerce behind it, right? How much money is involved in it? This is additional knowledge required. The economists can participate, commerce people can participate, right? Data scientists of any background, statisticians have got a major role here and so on. It's supposed to be a teamwork. So as I said, some examples of flower classification. So fruit grading, mango, during mango season, I'm not so good in deciding whether mango is matured enough to harvest or not, right? Okay, matured enough to harvest or not. Automatic classification of immature and mature mangoes, then ripened and unripened mangoes, right? So whether it is really good to eat or not. And certain mangoes are internally defected, but looking fine outside. Perhaps you must have seen in apples. When you cut the apple, you see black tissues inside, but outside apple looks so reddish. Then can I use my camera setup so that I take the picture? Then the moment I take the picture, without even cutting the apple, I should detect that there is something problem inside. It is not good to eat, so that I need not buy it. We are also working towards that detection of internal defect in mangoes. In fact, European governments have banned Indian mangoes in the year 2014 and 15 because of no technology to take care of and to classify or grade the mangoes. Unfortunate, right? So with this, there are several use cases which have worked in our laboratory. We worked on sign language automation, signature verification for banking applications. Sign language means deaf and dumb people use, no? So can we think of giving them a computer-based solutions for them so that they can use computers as translator? They need not carry somebody else who can explain the problem, looking at their signs. Can I have a mobile with a camera? If I sign in front of it, mobile should speak equivalent English, and so on. Classroom attendance, traffic signal alert system. Look, for your information, in my department, we have data analytics and learning laboratory. We have a specialized, computing facilities, and it is open for national level. Anybody can come and work with us. There are many people coming from outside Mysore and staying with us for 3 weeks, 1 week, and 3 months. And we give them good enough space to work and computing facilities, but they have to look after their accommodation and boarding outside. So we are here to extend our support computationally resources and also our human resource to guide them. But if something comes out, good research, then they have to either go with a co-authored publications or with a co-authored, patent filing and so on. So you can make use of it if you are really interested in our laboratory facilities. With this, if I sum up my lecture, friends, I just have spoken about science, fundamental science of AI, ML and DL, artificial intelligence, machine learning, and deep learning. And I just have spoken about some applications related to face recognition, activity detection, and PPE, personal, people protective equipment, safety jackets, ANPR, number plate reading, automation of that, and then Q count of vehicles, some international project examples I quoted. All in all, I just have touched upon various applications, use cases involving machine learning. With this, let me just acknowledge the organizers, HRDC of Mysore University, for having extended an invitation to be a part of this webinar series and to share my experience in the field of machine learning for you people who are voluntarily participating. And I should thank my research students who helped me in planning my slide content for the last 1 week to deliver this lecture. Thank you, one and all. Thank you very much.
Thank you, sir. Dear participants, now the webinar is open for discussion. If you have any queries, please go ahead.
People are there or not there?
Either.